morning, guys. Good morning, good afternoon. Depending wherever you are watching on the globe, we have embarked on our series that we have been carrying out last time. And today we are just going to proceed with our series of Titration Practical 6. So, we are just going to go straight to the procedure, and then we just answer the questions that are following. So, the procedure is here, Titration Practical 6. You are required with potassium carbonate solution, K1, 0.15 mole sulfuric acid, K2, methyl orange indicator. You are required to determine the concentration of potassium carbonate solution that is labeled K1 in grams per liter. So the procedure is here. Using a burette, measure 50 cubic centimeters of solution K1 and put it into 250 volumetric flask. Add about 150 of distilled water and shake well. Top up with the distilled water up to the mark. Shake the mixture and label this solution K3. Pipette 25 cubic centimeters of solution K2 into a clean conical flask. Add 2 to 3 drops of the methyl orange indicator and shake well. Fill the burette with the solution K3. Then procedures number 7, titrate the solution K2 with the solution K3 from the burette. Fill the results in the table below. So in this case, we are going to start with the following. We are going to start. We are just going to assume that we have carried out our titration and we have come up with these results. This is just an assumption. We have filled the burette and we have titrated our 3 titrations. So we have filled the burette with the K3 and then we have titrated it against K2. Okay? Against K2. Now, we are the questions that are following, we have been told to determine the average volume of the solution. Let us now assume that we filled the burette up to the zero mark, and then we have titrated, and then our solution changed at 42.7. Then it's changed at this mark, 42.7. Then we are going to refill the burette. Let us say we have refilled the burette up to the low Mensch's of 5. So we come here and write 5.0. So we assume now we have titrated and then it has changed to 46.8. Then we refill the burette again. Maybe we say we have refilled the burette up to the 0 mark. So we come and write here 0.0. And make sure all your tabulated results are supposed to be 1 decimal point results. That is the law of titration. So let us now assume that we have titrated and then it has changed to 41. Up to 41.8, somewhere 41.8 there. So, if you want to get the volume of the solution K3 used, we are going to subtract the final volume. We are going to subtract this volume from this. So we are going to get 42.7, and then here, if we do our mathematics clearly, we are supposed to get 41.8. Is it 41.8 or 41.8, right? 41.8 and then this one 41.8. So the questions here, it is requiring us to determine the volume of solution K3 used. So we are just going to write the average volume average volume of K3 is equals to first titer plus second titer plus third titer. And then we divide everything by 3. Everything is supposed to be in cubic centimeters. Right? So we write here cubic centimeters. So we are going to take this. For us to minimize the space, we are going to say this one is equals to 42.7 plus 41.8 plus 41.8. Everything is supposed to be in cubic centimeters. Then we divide everything by 3. So when we come back to our calculator here, we are just going to add them very fast. 42.7 plus 41.8 plus 41.8 is equals to 126. This one is going to give us 128. 126 only. 126.3 divided by 3. So when we divide 126.3 divided by 3, we get 42.1 cubic centimeters. Hope we have answered that one. Then we go to question B. This is question A. Then we go to question B. It says, determine the number of moles of potassium carbonate solution K1. B. Determine the number of moles of potassium carbonate that is solution K3 used. K1, sorry, solution K1 used. K1 used. So in this case, we are just going to say number of moles is equals to molarity times volume. Number of moles is equals to molarity times volume. So we are just going to make some substitutions here. We say this. If the molarity of K1 here, it is here. The molarity of K1 we have been given. Let us see. Molarity is of sulfuric acid is 0.05, 0.15 times the volume. It is 25 over 1,000. All these are the number of moles. So it's going to give us here it's going to give us, when you do your mathematics clearly, it's going to give us 0.00375 moles. 0.00375 moles. Question C. Question C. Determine the number of moles of sulfuric acid solution used. Determine, so we are going to say number of moles of sulfuric acid solution K3 used. So in this case, we must write an equation first, a well-balanced equation, so that it can be able to guide us in our calculations. So we are just going to say sulfuric acid plus potassium carbonate is going to give us potassium sulfate plus carbon dioxide plus water. Plus carbon dioxide plus water, like that. Liquid gas. This is potassium sulfate. So this is a 4. Then this is an aqueous. This is an aqueous. Also this one is an aqueous. So now we start comparing the products on the reactant side, and this is the product side. If the elements or the compounds on the reactant sides and the product sides balances, then our equation is self-balanced. So let us compare hydrogen. Hydrogen, we have 2 hydrogens here. Here we also have 2 hydrogens. Sulfate, we have 1 sulfate. Oxygens, how many oxygens do we have on the reactant sides? We have 4 oxygens plus these are 7. 7, and on this side we have 4, 6, 7. So the equation is balanced. So we write the mole ratio here. Mole ratio, volume, and then the molarity. So mole ratio here, mole ratio is 1:1. Then the volume, this one, remember sulfuric acid here in our equation. Sulfuric acid is the one that we have given it as K2. Then K1. Remember, we are titrating again K2 and K3 because it's the one, the resultant solution after we have diluted with some water. It is the one that we are calling what? K3. After we have diluted with some water in the volumetric flask. So now our potassium carbonate remains to be K1. Our K1 like that. So now the question is asking here. The question is asking, now, determine the number of moles of sulfuric acid K3 used. Remember K3, it is the resultant solution that we made within the volumetric flask. The one that we extracted from the original solution of sulfuric acid and we diluted it further. So, we have been asked to calculate, to determine the number of moles of sulfuric acid of solution K3. So we are going to do this. Because of their mole ratio here is the same, and we have found the number of moles of K1 here. So the number of moles, the number of moles here of K3, the number of moles, of K3, which is we have been told to determine the number of moles of K3. K3, it is sulfuric acid. This one, sulfuric acid. It is 0.0. It's supposed to be 0.00375 moles due to the mole ratio being 1:1. Due to the mole ratio being 1:1. So the number of the moles of sulfuric acid and potassium carbonate are the same because of the mole ratio is 1:1. Then we have been told to determine the number of moles of sulfuric acid. Just sit there. Sit there so that you can face me. Determine the number of moles. Determine the number of moles. We have been told to determine the number of moles. The number of moles of sulfuric acid. Determine the number of moles of sulfuric acid K3 in 250. K3 in 250 cubic centimeters solution. So in this case, we are just going to ask ourselves if the number of moles. We are just going to ask ourselves if the number of moles. Let me see. Determine the number of moles in 250. So we are just going to ask ourselves if we just ask ourselves if 48, this average, if 42.1 cubic centimeters can be able to give us, let me see, I beg your pardon. If 42.1 cubic centimeters is able to give us this number of moles, 0.00375 moles. What about in 250 cubic centimeters? How much is it going to give us? So we just cross multiply here so that we get 250 times 0.00375 over 42.1, like that. So it's going to give us that much. So we just do it very fast. 250 times 0.00375, we divide by 42.1. So it is giving us 0.22. 0.02226 moles. We have answered that because this is A, B, C, then D, We have answered D1, D Roman 1. Now we are answering D Roman 2. Now, D Roman 2. We have been told D Roman 2. Determine number of moles determine the number of moles of original the number of moles of original, remember it's original sulfuric acid solution K1 in 50 cubic centimeters. Acid solution in K1 solution K1 in 50 cubic centimeters solution. K1 in 50 cubic centimeters solution. Very simple. We are just going to take the number of moles in 250 then we are going to say the number of moles in 250 cubic centimeters is equals to the number of moles in 50 cubic centimeters solution. These ones here. In 250, they are the same that we have been asked here in 50 cubic centimeter solution. In 50 cubic centimeter solution. Which means it's going to be 0.0 226 moles because of that mole ratio. Number of moles are just the same. So now we are going to E. We are going to answer question E. Determine the molarity of the sulfuric acid solution. Determine the molarity of sulfuric acid solution. Sulfuric acid solution. This is solution, an abbreviation of solution. So we are going to say molarity is equals to number of moles divided by volume in liters. So now we are just going to make some substitution. 0.022 here, these ones, 22,226 over 50, this one here, 50, where is 50? 50 is somewhere here, 50 cubic centimeters, divided times 1,000. Times 1,000. So it's going to give us, if we just do our calculations properly, it's going to give us 0.0226 times 1,000 divided by 50. So it's going to give us 0.04452 m. This is the molarity of the sulfuric acid. So we have answered E. So we are going to answer the last question, which is F. We have been told to determine the concentration. The concentration of potassium carbonate solution, D. Potassium carbonate solution in grams per liter. So in this case, in grams per liter, whereby K is equals to 39.0, C is equals to 12, and O, which is oxygen, is equals to 16. Is equals to 16. So these are the relative atomic masses. So in this case, we are just going to get the relative atomic masses of each. Then, from there, we can be able to substitute. So the relative atomic mass of potassium carbonates is going to be potassium. The compound of potassium carbonate has got 2 atoms of potassium. So we are going to write 39 times 2.